Hello everyone, this video is about the improvement I made to the scroll view component of UI subsystem of Unity engine. And we made it to work. So the content of the scroll view would stick by its subobject to the corresponding sticky object added to the scroll view, the corresponding scroll view field. Alright, let's start from the test application, and it will explain how the sticky ScrollRect works. As one can see, it's just the usual two-dimensional canvas-based user UI application. It's the main camera, event system, game object, and of course the canvas. There are three objects of canvas. It's a scroll view, of course. It's a mirror which reflects the sticky points of each sticky point of the content, and the button which helps to enable and disable the stickiness of the scroll view object. There's a ScrollRect component of the scroll view game object, and I can see stickiness is disabled for now. And viewport, of course, content, which is field, which is altered by the content size theta and grid layout group, and 12 sticky sub object. We make it sticky by adding the corresponding component, which is called scroll sticky element. Right, I'll show you how it looks without masking. And check this out. Just the numpad. All right. Let me show how it works now. Okay, let's start the application. Game mode. As one can see, when we start the application and when the scroll view stickiness is disabled, then the ScrollRect works the way it was. Content just moved, and there is no any stickiness at all. You can see pushing to any button doesn't make content move anywhere. Right, when we enable the stickiness, the closest sticky element of the content moves to the sticky object, together with the content, of course. And then the stickiness is enabled. When you move the content, it cannot be left to any point rather than the sticky element stuck to the sticky object. As one can see, when the content reaches the sticky, starts move to the sticky element, corresponding event is raised, so we can notify the necessary game object by raising the corresponding function. When you push the spot, the content moves to the corresponding sticky element. And we can disable the stickiness and getting back the traditional ScrollRect behavior. When we enable it, the stickiness is back, and the content can be only stuck to the corresponding sticky elements. Let's get the short guide through the all ScrollRect options and how they affect the stickiness. So you can see when horizontal and vertical movement is enable it, then the content can move vertically and diagonally and horizontally and actually by under any angle you want. But when you disable, for example, the horizontal movement, the content can only move from up to down and vice versa. And of course, when you disable horizontal and vertical movement, the content cannot go anywhere. Alright, let's get it back. Movement type works here as well. So when you make movement type unrestricted, then there is no elasticity along the viewport borders, but since the content cannot be left at any port rather than at sticky elements, then when you release the content, it gets back to the closest sticky element. Alright. Of course, when the movement time is clamped, the content cannot get away from the viewport. So it must be it must always be with within the viewport. Alright, when we disable the inertia, the content moves only to the closest sticky element when you release it. So you cannot apply any inertia, any impulse to it. You can of course apply the impulse, but the content won't move automatically to the next point. Of course, when you get it back, by applying the impulse, you made the content move from one point to another. There is a new option I added. It's called drag sensitivity. So when you apply some impulse to content and release it, then the velocity you applied is multiplied by this coefficient. So for example, right now when you apply some impulse, then it halved and you release it. But if I made it this coefficient being 2, then the velocity must be twice. So as you can see, it was really fast. So you can reach really fast to any point you want. And of course it works without and with stickiness. Let's get the half volume. Alright, then sometimes it is necessary to make the content move inertially, but only to the next sticky point. So for this purpose, I made an additional flag. It's called sticky to one point. When you enable it and you apply some impulse to content, then it moves only to the next sticky point. Alright, the next option is a bit tricky. It's called sticky window. When you move the content, for example, from up to down, then the content moves inertially downward. But how to determine the next sticky point the content would stack to? I made the following algorithm. So there is a segment directed to the opposite direction from the content movement, and it analyzed all the points within this sector and moves the content to the closest one. Vice versa. So when you make it just 10 degrees, it's sometimes really tricky to make the content to find the next sticky point. That's why usually 30 degrees is pretty much enough, at least for this use case. But for example, you can make it 90 degrees, and in this way there's a bigger segment and it makes the content moves only inertially. It moves only to horizontal or vertical points, elements. See? All right. And of course, when you delete the sticky object from here, then the content, the sticky algorithm uses viewport to stick to. One would ask, what point is used to stick the content and the sticky object? I'll respond with the following. So the pivot point is used as the magnet point. So each sticky element has pivot point, and the sticky object has pivot point. So the content is stuck the way so its sticky element pivot point would be would match the sticky object pivot point. As one can see, if we get sticky object back, and now we move the pivot point of the sticky object, the content moves with it. All right. There are a few additional use cases. There are a few additional options I would like to present. First of all, if the content is configured so there is no any reachable scroll sticky element, then the stickiness is effectively disabled. So for example, if you disable all the scroll sticky element components, then the stickiness is disabled, and you can use just the ScrollRect. When you enable them back, then the stickiness is effectively enabled. If you move the sticky object, so some of the button, some of the sticky element would make the content to break the movement type, then those sticky elements are called unreachable, and they cannot be reached with the corresponding movement type. I'll show this way. For instance, let's move the sticky object maybe this point, and it makes the points lying on this place unreachable. So when you try to move the content, no matter how you try, those points cannot be reached, because the scroll view works with elastic movement type. And of course, the clamp's movement time doesn't let to do it as well. But when you make movement time is unrestricted, then all the points are reachable, because there is no viewport restriction of the content movement. All right. And now I would like to present how many processor time load stickiness adds. Let's get back sticky object. Right. As one can see, now when the stickiness is enabled, there are not that much processor load caused by the ScrollRect late update function. It's about 8%. Sometimes it's 9%. When you disable the stickiness, it usually takes actually about 5-6%. So it adds about just 3% of processor load. One should notice that this profiler graphs shows the runtime load of editor mode, but when you put the application to the build device, the picture is pretty much different. Okay, let's build the application. You enable stickiness. And put it into the device. Finally, it's done. So let's choose the active profiler as Android player, and it's started. As one can see, when the stickiness is enabled, the late update callback of the ScrollRect doesn't take more than 3% of the processor load when I start moving the content. When I disable stickiness, the profile doesn't change much. I keep moving the content. You're right, sometimes it's 6%, but mostly it's just 2% of processor time. Alright, I suppose it shows that the stickiness doesn't make too much overload, and of course it's pretty much useful for game development and for UI application development using Unity engine. And I hope the video was useful, and the improvement I've made is going to be useful for the Unity users, Unity engine, and game developers. Thanks for watching this video, and goodbye.